Hello, this is Gina Piscatelli with the last little bit of our third lecture for the week. I'm sorry that you have to keep watching a new lecture with a new link, but there's been some problems with this program that I'm using. So what we were talking about previously were the phases of the menstrual cycle and the phases of the uterine cycle. So there's three phases: the proliferative phase, the secretory phase, and the menstrual phase. That's assuming that fertilization and pregnancy don't occur. All three phases will happen in the uterus. In the first phase, the endometrium becomes thicker due to mitosis in the stratum functionalis and the stratum basalis. This is due to rising levels of estrogen, and the estrogen is produced by the developing follicles in the ovary. Once the follicles, or a specific follicle, becomes dominant, it ruptures and releases an oocyte, and that signifies ovulation. So an oocyte is released with its attached polar body. At this point, the follicle degenerates into a corpus luteum, but the corpus luteum makes progesterone, and progesterone is what causes the next phase of the uterine cycle, the secretory phase. And the secretory phase is characterized by increased thickening of the wall of the endometrium, or the uterus. Specifically, the stratum functionalis has glands called uterine glands that become highly coiled and secrete a glycogen-rich fluid that provides nutrients for a developing embryo. So the secretory phase is about preparing the endometrium for development of an embryo and a fetus. These glands also receive enhanced blood supply during the secretory phase, and that's due to the fact that the spiral arteries dilate. So we see vasodilation of the spiral arteries, and they vasodilate in response to progesterone, and the progesterone is being secreted by the corpus luteum. Eventually, if the oocyte is not fertilized, then this secretory phase is no longer needed. In addition, the corpus luteum will degenerate when fertilization doesn't happen. And if the corpus luteum is gone, then no more progesterone is secreted. And when progesterone is low, the spiral arteries now will constrict, and we'll see vasoconstriction of these spiral arteries, and the endometrium will become ischemic, necrotic, and the stratum functionalis will be sloughed off. So this is the menstrual phase of the uterine cycle, the loss of the stratum functionalis. Now you have a handout either from me or access to one on Blackboard that talks about the various influences from ovarian hormones upon the uterus. And I'd like to go through it with you. This connects the function of the ovarian hormones with the uterine cycle that we just reviewed. So recall that we have a proliferative phase where the stratum functionalis builds up again or thickens, and then we have a secretory phase where we see the endometrial glands become coiled and secrete a lot of nutrient-rich fluid. If pregnancy doesn't happen, then the menstrual phase will ensue. So let's see how the ovarian hormones cause the proliferative phase and the secretory phase in the uterus. So what we have happening in the ovary at the same time as the uterus is going through changes is first we have the growth of follicles, and eventually one is going to become the dominant follicle. This explains the increase in estrogen that we see, and it explains why estrogen is around to cause the stratum functionalis and basalis to undergo mitosis and thicken. Once that dominant follicle has been selected, estrogen really peaks high. And so you see a lot of proliferation of that stratum functionalis of the endometrium. Now there's positive feedback to the anterior pituitary by high levels of estrogen that we see here at number 5. And that high estrogen level causes the anterior pituitary to really boost how much luteinizing hormone it releases. That luteinizing hormone surge, we call it, causes ovulation. And so an oocyte is ovulated in response. It's just at that time that the endometrium needs to become nutrient rich and prepare for the possibility that the oocyte will be fertilized. And so what happens is the ruptured follicle turns into a corpus luteum. Now that ruptured follicle isn't producing as much estrogen. The corpus luteum does produce some, but what the corpus luteum is really known for is making a lot of progesterone. And that progesterone is what causes the vasodilation in the endometrium and the secretory phase of the endometrium. So it's perfect. It's perfect because the timing is perfect. The egg has just been released. The corpus luteum has made all this progesterone to prepare the uterus for the possibility that that oocyte is going to be fertilized. Now let's say no fertilization takes place, but we've got the uterus in this secretory phase, or the endometrium in the secretory phase. What happens? Well, without fertilization, the corpus luteum, it won't be maintained. And if it's not maintained, it's not going to make any more progesterone. So you'll see levels of progesterone decline. We do know that the corpus luteum turns into this structure called the corpus albicans that doesn't make any hormone. And so the decreased level of progesterone will cause vasoconstriction of those spiral arteries supplying the endometrium. That vasoconstriction then causes necrosis or ischemia, and then necrosis of the endometrium, and the stratum functionalis is sloughed off. And that begins what's known as the menstrual phase. So the menstrual phase begins here at the end, and then it wraps around to the beginning of this slide. So that's the status with how the ovary affects the uterus in the case where pregnancy doesn't occur. But what happens if fertilization does occur? Then what happens? The sperm has penetrated the corona radiata and touched the membrane of the oocyte. What does happen is the developing zygote turns into an embryo and forms the placenta. The embryo and the placenta release a hormone that replaces progesterone in a manner anyway, and it's called human chorionic gonadotropin, or HCG. Sometimes we just call that the pregnancy hormone. And HCG maintains that corpus luteum. So the corpus luteum will continue to make progesterone. Progesterone secretion continues. That maintains the secretory phase in the uterus and inhibits the release of follicle-stimulating hormone or luteinizing hormone, which we don't need anymore because we already have a developing embryo. We don't need to develop any more follicles, mature any oocytes at this point, or ovulate an oocyte. So that's what happens when fertilization does occur. I'd like to tell you just a few highlights regarding hormonal control in this lecture, which has turned out to be quite long. Let's review what we've covered. The hypothalamus at puberty begins making sufficient amounts of gonadotropin-releasing hormone, and that hormone stimulates the anterior pituitary gland to release follicle-stimulating hormone and luteinizing hormone. Follicle-stimulating hormone stimulates development of follicles, and they'll move from the primordial stage to the primary follicle stage to the secondary follicle stage, eventually to the antral follicle stage, where we have the possibility of a dominant follicle taking over and rupturing or releasing an oocyte. The luteinizing hormone, meanwhile, has affected the oocyte. It induces meiosis or oogenesis. So we have folliculogenesis and oogenesis happening kind of concurrently due to the action of the anterior pituitary hormones. Now, young follicles, as they're developing, secrete really low estrogen, but that dominant follicle releases a lot of estrogen. And that causes a surge in luteinizing hormone, because high levels of estrogen will actually have a positive feedback effect on the anterior pituitary. Meanwhile, what else estrogen is doing is causing proliferation of the stratum basalis to form a new stratum functionalis, because the last stratum functionalis was sloughed off at the end of the uterine cycle in the menstrual phase. So we've got preparation of the endometrium in the proliferative phase due to estrogen, and the high level of estrogen also causes an LH surge. That LH surge induces ovulation and transforms a ruptured follicle into the corpus luteum, and the corpus luteum starts making a lot of progesterone. The progesterone made by the corpus luteum in the ovary prepares the uterus for implantation of a fertilized egg. It does this by causing the spiral arteries to dilate, and therefore the endometrium and the endometrial glands will become bigger, thicker, and start secreting this glycogen-rich nutrient. Now, what would happen if implantation did not occur? Then what would happen is we would see a decline in progesterone, because the corpus luteum would degenerate into a corpus albicans. That decline in progesterone causes spiral arteries to constrict, and therefore the stratum functionalis becomes ischemic and necrotic, and we shed the stratum functionalis out of the uterus. Finally, that is the end of what was supposed to be one lecture, lecture number 3. Thank you very, very much for listening.